we need to synchronize. After you get your quiz, you get your quiz for last week, maybe you have some question. I can understand, but why you didn't give me any points? Why? Okay, so before that, I need to clarify. I need to clarify what's wrong between your answer and the answer I want. Okay. Okay. For the first question, it's very simple. It's very simple. You just write down Maxwell equations, but I want you to show in the right form. Okay? Of course, you can use different notations, but obviously, I want you to use the notation in the textbook and the notation I use here. The reason why is because the meaning of different notations here are different. The meaning. Okay, so some of you still don't get it. Some of you just write down many of the equations. They are different. So, but it is good for me to explain again because I think I already explained, but you didn't get it. So it's okay. It's okay. It is. If you answer 5 questions in the class, or if you can have like more than 15 points for all of your quiz, it's totally fine. Maximize 15. So don't worry about it, about your answer, how many points you get so far. You have a lot of opportunities in all the semesters to have 15 points. And then when you come here, you have 1 point. You got it, right? So maximize 15. The most important thing is you have to understand what I want, to understand the rules, okay? About the first one, I'm trying to ask you about what are the difference between E and E. Do you understand the difference? And this is I think most of you still don't get it. You still don't get what's the difference between that. Okay. First of all, they are both vectors, okay? We have no problem about that. All of you understand vectors. We use the notation of vectors to show, to describe electric field. Okay, that's no problem. But what are the difference between these two? Okay.
They're harmonic.
Yeah. Oh, you want to answer? Okay. Yes. No. Not quite sure. The reason we used here, you can see the where is it is not quite time harmonic. The reason I write down here, I tell you that, okay, for this part, you guys know, electric field is a function of your position and time, right? Okay? We can, all of you now understand, right? Where it is and when it is. And this is the function. Sometimes we didn't write it down, but this imply, this character, this notation imply 暗示, okay? The difference between this one because this one implies that we have a component of time. Time is a variable of this function. Okay, but I didn't write down. But actually, you can write that. Both of them is correct. Sometimes I write like this way, but sometimes I write everything. If I write everything here, means I try to remind you it is a function of x, y, z and t. 我试着去提醒你，它是它们的一个函数。Okay, I try to remind you, but sometimes I didn't write. Okay, okay. So the difference between this one and this one is actually I tried to explain a couple of weeks ago that if you say this is a function of time, then I will have so many possibles, so many possibilities, right? But actually, we can simplify the question because most of the time, our E field, it is time harmonic. Xu Yongsen just said that. What does that mean? I don't need to take care of the time because time harmonic means this is something times exponential j omega t. And the something here is only the function of x, y, z. Understand that? I have something, and if that one is time harmonic, it is not. I will not write down that this one equal this one. No. Not sure. It depends on your situation. Sometimes we are talking about only this one because your time component is simple. It's actually not simple. It is just very obvious. They have the rules. You just get this part outside, and the rest of the part we consider only x, y, z. It is a function of x, y, z, and the time only take this part outside. Okay. So it's like your E will become something times j omega t only. So it's not quite good yet. The final t here, if you want to write down x, y, z, and then there will be a sum vector, maybe something x, y, z, but the final, the total E field is you are only consider x, y, z part times the function of time part, okay? And this one is because after I tell you that it is a time harmonic function. These two are different. This is a total, okay? And this is only part of the electric field without consider the time, okay? If this E field can consider in this form, that means partial with respect to partial differential with respect to time will totally just direct to j omega. Okay. So after I tell you that it is a time harmonic equation, meaning E field is a type of something, only consider the position times exponential to the j omega t, which means this one can just write down j omega. It's easier. Okay? Okay. So where is my answer? And my answer is I try to understand how many students can understand what's the difference between differential and the integration form. This one is differential. You use the curl and use the divergence. This is the differential form, 微分形式. Okay? And when I write down this one means I don't know what is the time component of this equation. Okay? But once you know it is a time harmonic equation, you can just directly use these four equations. So no need to derive anything you don't need. For the first question, I just want you to copy these four sentences, these four equations. Okay? Okay? If you still have something you are not sure, maybe we can discuss later. Because this is time harmonic, I don't have this part, I can just directly write down J omega, okay? Because I already tell you it is time harmonic, I change the form from this one, I don't know what kind of time equation it is, I write down the normal notation of E and H. So are we good here? For the first question, you just copy it. If I say write down, you just write down. But if I say find something from something, you need the original source about what I'm trying to ask you. Okay, you need to explain why you understand. That is about the second question. Some people think, oh yeah, I understand. I understand what you are, now I'm talking about the answer for the second one. So the first question, okay, right? You just copy these four, because we are going to use these four equations again. So I want you to write down it is a phasor form, and the differential form, and the time harmonic, and the Maxwell equations. I want you to just write down, okay, the first question. For the second question, what I want is, what's the second question? Derive from the differential equation back to the, you use this equation, you use this equation, you use this equation, and you try to derive Gauss's law, right? For the second equation, okay. Some of you copy. It's not. It is not enough, because you need to show me you understand, not you know where it is, okay? That is, for the second question, only Cai Yueting, I show his answer on my website. I tell you that for the test and for presentation, those are different. Why? Because I want to present that, I will talk to you. I write down, I have the steps, right? First, what I have, then second, what do I have, and I derive, and finally, this is the answer. But if you copy my sentence, my equations on on your paper, I don't know if you understand or you just copy. You need to give me more clue. Let me understand how much you get, okay? You need to write down everything. Like for this part, I ask you, how can you derive Gauss's law from this one, right? So, what what you gonna do is, you are going to do is, you write down this one, this is the beginning. Because of this equation, and because this divergence theorem, you need to write down the reason. You cannot just copy this one. I don't think you know this relationship, you know this vector identity before this class. I don't think you know this before. Even you know, you still need to write it down. Because of this relationship, and I take a volume integration for both sides of this equation. Then for the left part, I use this one to change that to this. And for right part, because I take the volume integration of the charge density, I become Q. And finally, if you integrate the electric flux density for a closed surface equals to the total charge inside this surface, that is Gauss's law. Okay? Maybe you understand, but the problem is, that is why you cannot get your score even you understand. You need to persuade me you didn't just copy the answer. Especially for my midterm and the final exam, both of these exams are open book exam, right? If you just copy, I cannot tell the difference between copy and you already understand that. Okay? I don't want you just copy. I want you to tell me, yeah, how much you understand from the class. Are we good here? And that is actually a better attitude as a student. Don't just write down everything you don't understand, you don't know all the clue about this question. You need to clarify. You need to clarify what is how to explain this question, okay? And then always, if you know much, if you definitely understand what I'm asking, you can write it down better. This is how I tell you can get a point or not. Okay, so, moreover, don't write just equations. Even I use the arrow mark. This is the reason, and this is the original source. I use this equation to change that to this, right? You don't copy every sentence. I want you to write down, okay, because something, right? Also, we know something, therefore we got this result, and I organize that. Finally, I obtain something, and that is what you want. This is a habit to answer a question, not only this class. This is all for every class. You should have this habit. Okay? 养成好的习惯去写答案卷。Okay? If you always do that, you can make you understand and let me understand how much you understand. Okay? I learned a lot from you, from your quiz, that I need to tell you this. I need to tell you this. This is something you missed. If I just have the midterm, the final exam to you, you cannot get the point from me because I cannot tell. You can open book. How do I know? How do I know you really understand the answer? Okay? The answer is not where it is, it's what it is, how it is. Okay, write down, give me the, show me you understand. Okay, and some of you, like, you have the problem about writing the characters, maybe understand. The integration, write down like S, integration, you should do that larger. Okay, if it is this is a close integration, you need to write down. Some people do that, okay, it's fine, then I can understand. But some, I remember one of you write down S. And for the L, the though and the Y, they are different. Okay. I think most of you have the textbook. Try to write down clear characters to avoid problems. Okay? If you write down something they cannot tell, I can decide to give you point or not. Right? Okay? Don't just spend one more second, you can avoid the problems. Okay, and if you have other questions, you think you are better than your score, maybe we can discuss after class. But I think I try to make them very fair. I try to make it fair, and don't worry about that. You still have many opportunities to earn the points. Don't worry, don't worry. It's not easy to have the 15%. Okay, but this is one of the way. All right. So, is that? Do we need an air condition? Feel a little bit sweat. Not very cool inside. Last week, we spent about an hour to explain wave equations, right? Can anyone like to help us to review about wave equations? How do we derive wave equations, and what can wave equations do? Can anyone help other students to review? What are wave equations? You will earn an extra point. Anyone? Maybe just one of the questions will be fine. If you raise your hand, I say, okay, you got a card, you got 3 points, which means you have 3 more extra points from. It's like you totally okay about the last quiz. If you didn't get points, you answer a question, you can get 3 points. Anyone want to answer my questions? What are wave equations? How do we derive it? And what can you do? What is that useful for anything? Why do we need that? Try to shine. Or you want me to separate the questions one by one? What can wave equations do? Good question. What can wave equations do? we should have the 5 hours class because every time you go home you forget. We should continue what we are talking about, and I can say more. Okay, sure.
If we have two different mediums, then if we're going from one medium to another medium.
That's boundary conditions.
Yeah,
What wave equation? Your topic is the topic of the previous topic and the wave equations. So after we discuss about two medium, right? I'm talking about only one medium thing. About wave equation, do you have any idea why? Why do we need wave equation and how do we derive wave equations? Anyone? Just look at me, raise your hand, and we are going to write down these equations a lot. Right? Your first question for your quiz. Anyone? No? Don't be shy. No? Do you want me to remind for you? Sure.
Without outside source.
Huh?
Without outside
Oh,
source.
you are trying to derive it. Do you want to say that there is an easier question there? Why do we need wave equations? What do we need to describe? Why is this for? It's a function of wave equations. No? Okay, it's fine. We back to how to derive it, okay? Okay, you know how to derive it, right? Okay, first, you say, okay, please continue. Step 1, we have Maxwell's equations, right? Bessel form, and please continue. What you just said. First of all,
Source.
huh? Source,
Free source.
free source, right? Because sourceless, right? Okay. For if there is no source about Maxwell equations, then what can we do? Okay. If there is no source, which one is 0?
No.
Huh? Rho is 0 and
N and J.
huh?
N.
Who?
N and J.
N and J are
0.
0. Okay, good for the first step. How about the second step? Then we take the curl to which equation?
Up.
The first or second?
Fourth.
Number 4?
Four.
Fourth? Okay, we do one. Fine. We take first one, okay? Okay. So we take another minus j omega b. We take the curl to both sides of the first equation, okay? And then we use the magic about, how about, okay, we do easy way about this part. B equals to mu h, okay? So H can change this one to here, right? How about what is the curl edge? Curl edge equals to 2 huh?
Epsilon.
Curl
J omega.
J omega
Epsilon.
y. Too fast. Slow down. Where is curl edge? Can you find that from our whiteboard? No, don't look at your book. Look at here. Look at here. What is J? The curl edge. Can you find that from other equation?
J omega D.
Yes. Here, right? Equals to minus J omega mu times J omega D. Then you just told me that D equals to epsilon E. So J is minus 1. So it equals to omega mu epsilon omega square. Right. Okay, good. Almost. Yes, okay. Okay. This one equals to this part, and you will use some equation from what are the this one for this, okay, what is the result of if I take some vector, I take twice of the curl, it will equals to this part. Let me just write down. So equals to, it's different color to make you understand. The minus Laplace E, okay, this one equals to this one because of this equation, okay? Then, because this one implies that equals to 0, means this one is 0. So finally, you obtain minus Laplace E vector will equals to omega square times mu epsilon E, which means your Laplace of your equation of electric field plus omega square mu epsilon E equals to 0, and this is one of the wave equations. Okay? Just review what we did last week. Okay? And for this part is ugly. I want to make it simple. I try to define a new notation about this one. I call this K squared. Okay, so our wave equation can become an easy to understand format. The Laplace E plus K squared times E equals to 0, where K equals to omega times the square root of mu epsilon. This is one of the wave equation, and we can do the same thing. Maybe I can ask you in the midterm to derive another wave equation. Should be easy, right? If you can follow, should be easy. You just change E to H. Do similar thing for H. Okay, so back to my first question. What can we do? Why it is useful for the wave equation? Why? Look back to Maxwell's equations. Okay. We just look at these two Gaussian equations at the beginning. We take the divergence of something related to E field. D is epsilon times E field, right? Okay. If I take the divergence, this one become a value, a scalar. This is not a vector, it is a scalar, right? I know how many charges inside the area or something like that. I take E, okay? I take divergence of the B equal 0 because we don't have the magnetic charge in the world, okay? Those are the equations only related to E field and only related to H field, right? This is the E field to some number, and the H field, I take the divergence. The vector of H field equals to a number. Those are scalar number, okay? Okay. We don't know what are E field and the H field. We don't have enough information. We don't have enough information because it is number. They are scalar. It's not easy to understand what are E and what are E and the H field. It's not easy to understand. Those are scalar equations. Okay. For those more complex equations, for the first one, I can just change back to J omega B, and then only this one with or without source. For those two equations, E field equals to something times H field. The curl of E field, it is still the vector. Curl of a vector equals to another vector. E and H, they show up together. They have a relationship, right? You curl E equals something related to H. You curl H equals something times multiply your E, right? You can just write down J omega epsilon E. So this is what I call something. You curl H equals something times E, right? They show up together. They have a relationship. E become something about H. H is related to something times E. Okay. But the thing is, so what is E? What is H? People try to understand what's that. After we do the derivation of the wave equations, we can find an equation only has a relationship. We have the information about only E or only H. E field will always obey the rule. H field will always obey the rule. Both of them are field, right? Are waves, and they look similar. Okay, so this is the function. This is the use of wave equations. That's what we stopped here last week. Okay, we stopped here last week too. Okay, so E and H looks like that. They have the relationship about themselves. Okay, so our next step is to solve this equation and solve this equation. They are both the second order of the partial differential equations. Maybe you should heard that from your calculus class before, or not. Maybe, I don't know. You are supposed to learn this before. The second order PDE, partial differential equation, because this is second order. Okay? So how to solve it? How to solve the equations? There is one more condition we need to think before we solve the equations. If you think too much about E field and the H field, there are so many possibilities. We know E field is a function of x, y, z times the exponential of j omega t, right? This is what we know so far. Because if that is a time harmonic field, you have this extra term talk about time. And actually your final E field is something only related to x, y, z times this one. Okay? Okay? Are we good? So, but it is too complex to use x, y, z. Can we discuss if the E field, it is a uniform wave, looks like that? Can we discuss like that? I give you an example, like if I have a charge here, right? We discussed this at the very beginning of this class. If I have a charge here, then I have the E field. Maybe I should write it down here. What is E field? E field is, I have a charge. Do you remember this? Do you remember this one? I put a charge here, and if I put another charge here, you will suffer the force to push it out. Do you remember this one? That is E field. That is E field. I put another charge here, and I push it out. So because it is how to say, isotropic, so I put a charge here. So I only consider the distance between these two charges. I don't care where it is. I consider the R between these charges here, the R of the charge is here, but what is the distance between these two charges? And the charge will suffer a field to push it out. It's like there exists an E field here. After then, if I put a charge there, I will suffer some magic force. Okay, so it looks like there is an E field, right? But if you consider this shape of the E field, it is not easy to explain that in math, right? How you can write down? It's of course it can be write down, but it will not easy to be understand. If there is a E field, you try to explain this kind of E field. So what can we do here is we try to explain the E field very, very long, very, very far away from the source. We try to look at the field far away this source. If I am very far away from the charge, it looks like all the field is uniform at this surface and different because it's only related to the distance. So only related to the distance between me and the charge, but uniform in another two directions. Is that clear? So I try to simplify the question from a complex situation to a plane wave. Okay, maybe we can take a rest. Okay, I will deal with Abi first and I will use Chinese to explain. You understand what I'm going to do? Is that totally fine?
Yeah.
Okay, so we try to make it easier, use the plane wave. It is a wave far away from the source. And it is very easy to understand because only we have x, y, z, the variables x, y, z, right? We just need to consider only one of that. Like the distance between us is z, and the x, y, they are uniform. Okay? Okay. Okay, I'm trying to use Chinese to explain. Okay, so Okay? If this is the direction of E field, we will have the direction of H. It's outside the, okay? And this wave, they are moving is the direction of E cross H. This is the direction of wave moving. How to define the direction of wave moving? This is the direction of energy propagating. Your energy is going to this way, but your E field is going to this way, but H field is going. They always show up together. I'm just tell you the result. I haven't explained yet. I will explain soon. Okay? I try to use this one. I try to make this easy. I change that to this one. I can write down like maybe the direction E is a scalar function times the function of x multiplied by move that to the way. Can you understand? 为什么会解释? Okay, we try to explain that by using the plane wave. So this one can happen, right? This is only the function of this one. And this will be the direction of only S, and we will explain why. How to explain that? Through this equation, wave equation. We need to use this equation to explain and what it is. Now we simplify the equation from something we don't know to only this part. And see, looks like easier to understand. It is only a component of Z. Okay. Generally, our E field has three directions of the component. It is an accumulation of X direction field and Y direction E field and Z direction field, okay? Generally. So for the real world, for your E field, you have the XYZ component. There are many possibilities, right? It's general way. But if you consider only S component, you think, maybe I want to make it easier. I want to see these two terms. If there is a field, we consider only one direction. You can write it down. And also, if that is a plane wave, uniform in X and Y direction. Plane wave is what we talk about. We don't have the component of X and Y. We only consider Z. We simplify the equation to this one, this term, and to T. Because of the definition of the Laplace equation, the Laplace operator, this one. Laplace is an operator of I take the Laplace of each term, but because I have only x part left, so I took the scalar function of Ex. I use the double partial differential to x and y and z. Okay, And because I told you that it is uniform, it is a plane wave, I don't have the component of x and y, right? So I have only this term left. So I can, therefore, I can change this one to
There will be square because it's double differential z.
Square.
It should be z square.
oh yeah. Oh yes. Yeah, correct. Very good. But you still got a card today? No? Not yet? Okay, I can give you one. It's a nice, you can correct. So, your wave equation can become this one. You understand? Can you guys follow? Because of this is a uniform plane wave, uniform to the direction of x and y, and it is a wave only direction to the x, only x component. Your E has only one direction. E is only an x direction, x component, and it is a function of z. So you will have this one instead of the Laplace. You guys need a bit of time. You guys, and I can use Chinese to explain again. You guys, 有没有还不懂的？直接跟我说。Can get rid of the unit vector of x, right? Okay, the same equation. So this one become a scalar equation. Then what we need to do is to solve the equation of and this is a partial second order of the partial differential equation. E will equals to something we don't know times minus j k z plus another something we don't know times exponential plus j k z. And we in the calculus class we will prove that. Maybe you have some memory about this one. Okay? Will become something. What is something? We don't know. We don't know. Okay. So we have we gave it a name. What did I call? Is that E plus E0 plus or E0 minus? Let me see. Can you all of you see that? maybe you have a question about why, but this is that this equation is solved in a calculus class. 微积分课讲说这个东西解是长这样。Therefore, the magnitude we don't know, but you always have the form of the exponential to minus jkz and exponential plus jkz. Okay? Okay? That is E of z. Let me see. Use the same notation or not? Okay, so there's no zero. It's a name, just a name. This is something times exponential minus jkz plus exponential minus e minus times exponential to the plus positive jkz. And this is a phasor form. And this is a solution. This is the answer of this PDE equation. Okay? You don't need to struggle in why this one become that one. You will get used to that. For this equation, the answer is this one, and we don't know E plus and E minus. We don't know. We don't know those magnitude. What are those magnitude? We don't know. But we know we will have the component of exponential minus jkz and plus jkz. Okay? Okay? So, what do we have now? Our E field can be described in this form. We can say, oh, so this is what E field looks like. Do you remember that exponential to something we can write down to, let me write down. Do you remember the Euler equation? If there is a theta, right? Exponential j theta equals to cosine theta plus j sine theta. Do you remember that? Because if this is a complex coordinate, complex, and this is a real, this is an imaginary I and RE, okay, real part, imaginary part. You point here, this is cosine theta. If this is 1, this is cosine theta. And then if this is 2, it's 2 cosine theta. So if the distance between here to the original point is A cosine theta. And for this part is A times sine theta. Remember, right? Okay. So if you remember this one, look at our answer here. This one is J times minus KZ. Okay? And actually, your total E is, go back to what we have the assumption from the beginning. I already erased it. E total equals to EZ multiply the J omega T, and E is the x direction, right? And this part is this part. Okay? We can write down E total equals to E plus times exponential, if you have exponential j omega t times exponential minus j kz, we obtain j omega t minus kz plus exponential e minus multiply exponential j omega t plus kz, and all of this direction going to x. This is the actually the original E fields looks like. Okay, anyone can follow? No?
Oops.
Okay, too much? You can follow? Yes? Okay. Why I say that? Because this one and then this one can be think like there's theta here. So the real part of that, it is E plus, if I say the real part of the E total will equals to this part times cosine omega t minus kz plus E minus cosine omega t plus kz. And the real part of that, so I need to multiply by x. Okay. So this is what we usually looks like. The E field is a function of cosine because it's only a real part. And then this is theta. This one or this one is the theta we talk a lot. The phase. The phase. Phase means if there is a wave, how many degree that is, how long it is in the electrical meaning. Is that too fast, too much? So this is what I'm going to write down. And for this part is, there is a cosine wave, right? If I look at only the real part of the E field, this is a cosine wave. And this is a phase where it is. The phase is a component of omega t 2 pi frequency times the time minus your k, something we define k equals to omega times the square root of mu epsilon times your position z, how long it is, how far it is, your position, where it is. Okay. Let me show you guys. Okay, totally fine. You sure? Okay, so I explain again to other guys. Phase is very important for your circuit design. If you want to design circuit, you will say how many degree of the length, how many wavelengths is your physical length. How many degree? Maybe 90 degree. Maybe there is a quarter wave transmission line. Maybe there is a half wave resonator. You want to design a filter. You also use a half wave resonator. Okay? So this is how it comes from. So this is very important at the beginning. Everyone should understand the phase. Now we spend some time to talk about what is omega t minus kz or omega t plus kz. I write down omega t minus kz or omega t plus kz. It is the definition of this one is theta. We call it phase. Or sometimes we call that theta is a electrical length. It is a length, but electrical length. We have many things to describe that on your circuit. We will have a more detailed explanation after your midterm exam. Let me write down some name of theta. Okay, you will see that very usually you will say, okay, that is phase sometimes. And sometimes you call that theta equals to electrical length. It's not a physical length. Or sometimes we will set your physical length maybe how many lambda it is. We are talking about very similar things. For circuit design, you manufacture a physical length of your microstrip line or coaxial cable or waveguide. You manufacture a microwave lines in many different forms. You make it. When you make it, you have a physical length. You can use your ruler or other ways to say how many millimeters or how many centimeters or maybe how many meters of your line, how many lines. But because we trying to propagate our signal through your microstrip line or maybe your I will call that microwave lines, high frequency lines. You want to propagate the signals. You have different signals at different frequencies, right? So in different situation of the different frequencies of the signal, your physical length has a different meaning to different frequencies. Different meaning, okay? If your frequency is very, very low, like a DC, DC means F equals to 0, right? There's no frequency. That means your wavelength is infinite long. So any physical line is a point. There is no length of the physical for all of the physical lengths at DC, because your F equals to 0, which means your wavelength lambda equals to infinite. Everything is a point. You don't see any line in DC. You are getting higher and higher frequencies. Your frequency is getting higher and higher, which means your wavelength is getting smaller and smaller. Okay, if this is a wavelength, your one wavelength, this one may be 30 degrees. You change 30 degrees of your waveform. Okay, this is a physical meaning. Okay. Moreover, we know our wave will propagate according to your physical position and also will changing according to the time. When the time is changing, you will follow your time harmonic function. Actually, this is a cosine omega t. So when time is changing, this one maybe you will have different meaning of your maybe voltage, current, or H field or E field. Okay? They are in a very similar form. Therefore, we talk about phase. That is phase. This part is what we calculate, what we obtain from our derivation from our wave equations. This part. Actually, this is the term of cosine theta. This is cosine theta. This is theta. You know your E fields looks like something times cosine theta plus something times another cosine theta, right? They are a little bit different. There are two cosine theta. The theta, we call that phase, where it is for your cosine function, where it is, okay? So, let's look at omega t plus or minus kz. Okay. Theta equals to omega t, let's look at only one part, okay? Minus kz. Okay, we try to pick up what they are, okay? What is omega? Omega equals to 2 pi f. This is what we know about angular frequency. So, about the frequency here. Times t minus kz. What is k? K is, we define k from the wave equations. K equals to, from the material, we said that is omega times square root of mu epsilon times z. Okay, but it is not very helpful here. It is not very helpful here. We try to think about how to explain the k, okay? We try to explain what is k. We put this question mark here. This is actually something we know k equals to omega times mu epsilon, but I don't want it. I don't want it yet. I want you to put only, still put a k. You just keep in mind k equals to omega times u mu epsilon. This is a material, right? Mu and epsilon is that d equals to epsilon multiply e, and the b equals mu times h, right? This is a material. Where you are about where your field is. Okay, just keep in mind, but I don't want something about that yet. What is the definition of f? F means how many times a second, right? Frequency means how many times. 1 second. And in 1 second, how many times repeat your wave? How many times? So, F equals to, do you know, T. F and T is different. T is a period. How to say that? Period. It's how long if I happen one time. How long one time? And the F means how many times for 1 second. There are difference. For example, in 1 time, in 1 second, if this happen 5 times, which means your F equals 5, right? So every time you happen 1 time, it's 0.2 second. So your T is 0.2 if your F equals to 5. This is a period. 周期. 周期. Okay. That's a physical, very basic physical sense. Okay. So you can write down this t is a period. You can write down like 2 pi times your t over time. They are different. T means for one loop, a cycle, how long it is. And this t is changing. This is unknown. A small t here, that is when, now. When is now. It's 0 or 1 or 2, then you can know this one is, you can see, small t is the time at the moment you want to calculate. And t is the period of this circuit, of this wave, the period. Okay? So you can multiply this term to 2 pi. If your t equals to your period, which means there is a loop. You come back, there is a cosine. You from 0 back to your original part. It is 2 pi. Okay? If your small t equals to your period, it is 2 pi. Cosine 2 pi equals to cosine 0, right? This is cosine. So this is, we are talking about that one. So you can see that for this term, we are talking about time. You changing again and again according to time, and where you are according to how many period, how many percentage of your period is. Okay? Minus, let's just neglect this part. Don't worry about that. I want to do something multiplied by z. This is time. This is a space where it is. What happened for there is a physically meaning of a loop. What happened? If that happened again, we call that a wavelength. Okay? In a physical meaning, if I told you that this is one wavelength, means my wave on that, there is a complete from 0 degree to your maybe 3 and the 2 pi, right, for the cosine. Okay? If there is a loop, so this is a 1 lambda physically. So I write down like this must be something related to 2 pi, similar to this one. Your physical meaning of a loop, it is a lambda. Okay? Your length compared to a complete wave, lambda. This is how long your circuit is, right? Your physical position. This is your time at the moment. Compared to a whole time for a period is over by t, and this physical loop is a lambda. You guys understand? And you need to multiply by 2 pi because every time this is the percentage, how many times for a whole loop. Because this is a cosine function. Everyone understand?
So, Professor, t and lambda will be fixed for a wave, right?
What's that?
T and lambda will be fixed.
and
Lambda
T and the lambda.
will be fixed for a wave.
This one is the wave, how long it is. And the T, yes, of course, is the period of the wave. And then this is the wavelength of the wave. Yeah, yeah. I think you explained. You explained something. For the full wave, you think about what is the full wave in the time concept. The full wave is a period, T. But in the physical, the space situation, you consider what is the full wave in the physical, in the space. It is a lambda, right? OK， 听得懂吗，各位？在时间上，一个波它是一个周期嘛。那在物理上，一个波是一个波长嘛。那我这个东西是考虑波长，又考虑时间，又考虑空间，因为它会随着时间动，也会跟着位置动。所以我讲这两个地方的话，就是解释了所有的东西，也解释了这个地方。OK， Therefore, now we realize that so this is your K. Right? K sometimes equals to beta, sometimes, and then this one equals to 2 pi over lambda. That's why. 2 pi times your position divided by your wavelength. You can see how many contribution about your Z can change your phase. Okay? Time, space. Think about funnels, right? Times and the space. You have space stone, you have time stone, right? Different dimension, but both of these can contribute to have different phase. This is why I write down this one. Okay. So, if I change the time, because we cannot reverse the time, so I have only one direction of this term, always positive. Okay? But we have different direction of our physics meaning about negative Z or positive Z. So it is possible I have a minus or positive sign of this one. It depends on which direction your wave is propagating. Okay? Then it's going to the next step to have some example. Now you have equations, right? Okay, you can write down in the form you are comfortable about. Write down that maybe you will have some quiz, give you some questions. Try to now you can calculate something. Okay. So. First of all, sometimes we will hear about the phase velocity. I said the wave is propagating, right? How fast it is? How fast my wave can propagate? How fast? Okay. So if we try to calculate the velocity, we usually doing something to partial differential with respect to time, right? How fast it is, okay? If there is a wave is propagating, how can we monitor? When you see, okay, for example, you say, when you say this wave is propagating, if you say the wave is moving, how do we describe that it is moving? How? We try to monitor, we try to see that, okay, when at t equals 0, it is here, okay? At the beginning, it is here. And after all, it's moved to another position. This is x. Okay, let's say maybe you use z. When t equals 0, it's here, and when t equals maybe 1, it moved to another place. Okay, how do we know it's moving? We try to understand that for this point here, and then this point here, it changed the position from here to here, right? Okay, so if we try to understand that it's moving, we try to take a partial differential to with time. We make it equal 0, means the same position changing to another place. Okay? It's a definition of time. And then we try to solve this equation. We divide by t become omega minus k times dz dt. This term is the distance over time. This is the velocity of our wave. This is our definition of Vp. Okay? Vp equals to dz dt equals to, you can see that from this equation, you can obtain that Vp equals to omega over k. And we know k equals to omega times the square root of mu epsilon. Right? So Vp equals to 1 over square root of mu epsilon. Okay? And at the beginning, when we discussed about mu and epsilon in the air or free space, mu is mu 0, epsilon is epsilon 0, right? You know mu and mu 0 and epsilon 0, they have some specific numbers. Right? For the mu 0 is 4 pi times 10 to the minus 7. For the epsilon 0 is 8.854 times 10 to the minus 12. Okay? They are just numbers. You put it inside, will equal to c. C is 3 times 2, 3 multiplied by 10 to the power 8 is the speed of light. So we derive that your wave propagates in the air. The phase velocity of your wave is the same as the speed of light. You just put this number in, you can get that. 3 times 10 to the power 8 speed of light. 光速. You got it? Right? Okay, let me just. 你们听得懂吗？
Yeah.
OK， 你不懂，现在就讲，因为我会要你们算板子里的速度或什么有的没有的速度了，听得懂 ？OK。The first of all, you should understand why Vp equals to omega over k. Okay, that's the first thing. Because of you fix one point, you use the partial derivative, you say that equals to 0, not changing, equals to the time. You have this equation, and you obtain this part. So this term is Vp. From this equation, you know Vp equals to omega over k. Okay? How fast your wave is. Okay? Then you just put k equals to omega times square root of mu epsilon here. You divide, you cancel your omega, and you obtain that. How fast your wave is only depends on what it is, what the material is. Okay? No matter what wave is, if your wave is propagating in the air, their phase velocity is the same. Okay? All the waves propagate in the same material, their phase velocity is the same. You propagate in the air, you use this equation, you obtain your Vp equals to the speed of light. And you propagate in some, I don't know, material, you have different mu zero, you have different mu and a different alpha. You have the same Vp. All the wave, how fast the wave is depends on only the material, what the material is. Okay? 你们听得懂吗？只跟材料有关，跑得多快只跟材料有关。I already explained, right? I already explained that the contribution of the time and the contribution of z. This is a contribution of the time. So you change. And I think I don't need to explain too much about that. I already talked about that. So this is what we discussed. Yeah, this is what the k is. K equals to 2 pi over lambda, right? And also, you can trace back from the equations. Because k equals to 2 pi over lambda, right? You also say lambda equals to 2 pi over k. And we know k equals to omega over Vp. Because Vp equals to k over omega. And from that, you know 2 pi over omega can be cancelled, and then we left f here because omega equals to 2 pi times f. So you can get this one. What is that? Vp, you guys learn from that c equals to lambda times f. Do you know that? The speed of light equals to lambda times frequency, right? You know this one, right?
Yeah.
This is what we got. Vp is c, lambda times f. So we use this one to derive something we already knew. We knew this very long time ago, right? I just put the definition of k inside equals to Vp over omega. Everything you can use a different way to explain that. All of them make sense. So lambda is Vp over f, which means c equals to f times lambda. Okay? They finally can prove each other. Okay? Everyone? if you have question, do you want me to stop or I can go on? You need to time to digest what I say, or you want to go on? If everyone is okay, then I just go on and give you more equations, tell you more. Okay. No matter what happened, I will finish chapter 1 before the midterm. Okay. If I can finish that earlier, maybe we can go through some detail about different part of the chapter 1. Yeah, now you can understand why we need just only focus on chapter 1, right? There are too many details you need to digest. Not go rush. Okay. I think I still have a little bit time to talk about the wave impedance and then finish this part, and then we can do another part for next week. Wave impedance. What is the impedance for your circuit? Impedance is the before you at the beginning for everyone to learn to in the field of electrical engineering or electronic engineering, everyone know V equals I R, right? Everyone know that the voltage equals to current times your resistor. Okay? After you learn AC, current, you know there are some phases about voltage and the current. So you use V equaled, I put the R here. After you learn AC current, you say V equals to Z times I, right? Because we need a complex impedance to describe the phase of voltage and current. So we will need Z equals to R plus JX. If that is the AC. If this is a DC, we use this one. If this is AC, we need complex impedance. We call this impedance. And this is only resistance. This is only the real part of the impedance. Okay? This is the impedance of the circuit. For wave, the wave we are talking about here, we're trying to use very similar way to describe the relationship between E field and H field. But the direction, you cannot use this one. So, we're trying to say if E equals to maybe EX in one direction, okay? Multiply, I don't take the time component. I write down only for the XYZ component, okay? You just multiply back. Only S part times X and H equals to because they are perpendicular to each other. If I do that, right? Can I have a relationship between EX and HY? We can write down EX equals to something owning the magnitude. How big it is from that, okay? This is a scalar equation. Vector, I think about this part and this part. Is there any relationship between this one? Okay? And this is a wave impedance, or I call this some different part. They use different notation on there. Eta. It's impedance between E and H, but only in the scalar function. Okay, between that. Okay, how do we find this one? We use Maxwell's equations. At this time, what do we have? I directly put everything inside here. At this moment, I already know if there is a plane wave, your E has only a component of EX. You can write down like E equals to only EX, only this term. So when you do the calculation of your curl E, you write down this part. Okay? Everyone understand about this part? You don't have E, Y, and EZ. You have only EX because of it is a plane wave. Has only the component of X. Okay? Equals to, you just copy, minus J omega mu H. This one equals to that one, okay? And for this curl term, you can obtain this term. You have this component, and your EX is only a function of Z. So you have left only this part, and the direction is Y. Anyone follow me? Okay.
那个符号在哪里？
哪一个？
那个红色的符号，
红色，哪里有红色？
就是你 EX
他说 impedance，他是黑板写的，白板写
哦，
的。
还没，快了。你先把方程式写出来，然后除过去就是啊，那也。This is wave impedance we try to obtain, right? We obtain this from Maxwell equation. Where can you have a relationship between E and H? Your first equation is there's an E, there's an H, right? I just write down, and then at this time I know E is only a component of X, 0, 0, and the EX has only a component of Z, it's a function of Z only, right? So you are left only this part. Okay? Your curl E now can simplify to only this part. It's not curl E that's scary. Now it's very friendly. Right? Looks very friendly, not curl. Curl is ugly because the curl looks like this term, right? You don't know why it is. Because they are 0, 0, and it has only a component, it's a function of Z, so you can write down only this part. Okay, so blue box equals to blue box, then you can find eta. 这样我们回答。
那要怎么写？
哦，只是怎么写而已，不是这样写。Okay, so we find a relationship between this one and this one, right? Now we have a little bit problem. What is the problem? What is EX partial differential to Z? What is that? Back to the result we obtained a couple hours ago, 1 hour ago. This is EX, right? This is what EX looks like, right? You directly do the partial differential to Z to him. Then you can obtain minus J omega mu H equals to something. See, now become Y. And this term, you get a relationship between that. So you obtain, finally you obtain HY equal to this one. Okay? Then, yeah. It is the ratio between E and the H. E equals to something multiplied by H. So this one is this one. It is the relationship, the ratio between E field and the H field. Only the magnitude, not the direction. We don't talk about it because when you do the curl, your direction will go to Y, right? Actually, you can find the change of the direction by using the Maxwell equations. So this one is here. Furthermore, if Vp equals to omega over K equals to 1 over square root of mu epsilon, this is what we did. We derived for the phase velocity. The epsilon equals to this one. You just put everything in, and you obtain epsilon equals to your eta. Call this eta. Eta. Okay, eta. Eta equals to omega times mu over K equals to the square root of mu over epsilon. So, different material, different impedance. So for the free space, you can calculate, you put a mu 0 after epsilon 0 inside, is 377. We all remember if you are in this field. For the air, the ratio between E field and H field is 377. Oh. We have many questions, and we can have some questions now, right? Okay, I think that's okay. I think I can finish up then. So this is what happened in the real case. I explained a lot. If this is X, the red one, you have a field to the X. And for the blue one, is the direction of H, is Y. And then your wave is propagating in Z direction. I think it's X, Y, propagating in Z direction. X equals to Y equals to Z. X, Y. The direction is a little bit misleading. You know what I mean, right? E, H, and the wave propagating, they are all propagating to each other. Propagation, propagating, propagation, and propagating. Okay. And this one is not correct. No, should be go this way. Sorry. S, H, Y, H, E, H, and the P. P is the power, where the power goes. 这个图是错的哦，它的方向应该是往下来，对 ，E H，OK，
It's right.
No, it's not correct. I don't know why. Yeah, E close. We will have more about that. E close H to P. Okay, that's it for today, for this week. Everyone, understand? Maybe I will ask you some question next week, so please review. Please
太多
review.
公式背不完。
所以叫你们 open book。open book 不是那个，是因为多到我都觉得说太残忍了，才叫你们 open book。你可以看着书考，但是你要会用。
会用。
你没有想过为什么我那么好会给你 open book？是因为多到我觉得说算了，不要背了。但是你要知道怎么他在干嘛，对不对？没事，干嘛给你 open？ 我们社评有让我们 open book 吗？没有啊，只是把公式抄给你而已。
忘记了。
对啊，为什么社评没有 open book， 这个要 open book？ 因为这个公式就是多到你会记不起来，你连看着书你都不知道怎么用，好不好 ？OK。好，先这样，你们有没有还有疑问的，你可以跟老师再 confirm 一下，说你自己知不知道说在干嘛？哦，我有时候会出一些东西来确认一下你到底听懂到哪里，然后有时候我来不及了，因为这个东西你到现在第一章还上不到一半。那还讲不到一半，那哦，因为人家听说你们期中考才上一章，感觉上太少，对不对？有原因的，有原因的。好来，就这样吧。好，下个礼拜见。哎，下礼拜要放假吗？没有啊？没有。OK，可以。